Design of Raft/Mat Foundation in CSI SAFE software. In this video, I will discuss step by step for the designing of Mat/Raft Foundation. Here I will click File, New Model. Here is the design code. You can select according to your country. Design preferences. Okay, code. These are the design factors. Please do not change these factors. And minimum cover slabs. If you are designing the foundation, please make it 50 millimeter, which is 2 inch. The preferred bar size that we can change it later, but here right now it's a 16 millimeter, and that's the rest of we left. And that is the minimum cover of beam post tension. Okay, then project information, you can put the project information. Okay, then here is the unit system. I will select the metric. You can select FPS system, but here in this problem I am selecting the metric system. Okay, then there are options. I want to start from a blank, from a templates that are present, from a grid only. So I will definitely start from a scratch file from 0 level. I will click blank document. Okay, now I will define the grid system. Edit, add/modify grids, modify spacing. Okay, so here I will define 1 by 1 grid: A, B, C, D, E, F. Okay, here is the spacing between the grids: 5, 6, 6, 7, 5, 0. Okay, now for the Y grid data 1, 2, 3, 4, 5, 6, or you can do it more, 7. The spacing is 7, 6, 6, 5, 7, 6 and 7. Okay, that's the grid. And general grid data, I will just illustrate you some how it works. You can draw in the inclined grids. For example, I'm making x1 and the point is 0, 0, and that will be, for example, 15, 15. Here you can see I can draw the inclined grids according to my requirement, but I do not need in this problem, so I will just hide it. Click hide. Okay, now the rest of the grid is appearing. The inclined grid is not appearing because I have hide that grid. So now I will define the material property. Here the predefined 30 megapascal concrete, so I will take it as, you can define the new material, and the grade 420 megapascal, so 400, so I will making it to 420. Ultimate will be 620. These are the 60 grade steel. Okay. Now I will define the slab property and new property. Here I will define the mat foundation. Mat that will be, for example, of 700 millimeter thickness. Mat foundation 700 millimeter. Okay. Now I will define for the stiff columns. Add copy of this stiff column. Okay. Now it's a stiff column. Its thickness will be also 700 millimeter. Okay. Now before drawing the grid, I will check the load pattern. Define load patterns. Here is dead and live. You can add more. For example, wind, snow, etc. Okay. Define load combinations. I will click add default design combination. Strength ultimate and service normal. Service normal are 1 dead plus 1 live, and these are the strength combination: 1.2 dead plus 1.6 live. Okay. Now for drawing of slab there are different options. Now I will select draw slab from here. That's the property straight line. You can also draw the inclined, curve or multilinear slab. So in this example I will select straight line. I will start from here. That is a mat 700. I will click enter. Software automatically draw the mat foundation. Now I will make the offset, because when columns come here then the 50% column will be outside, so more than 50%. So to make in the grid we have to make the offset of the slab. I will select the slab, edit, edit areas, expand slash link. If I will put positive value then the offset will be outside. If I will put negative value the offset will be inward. So here I am making the offset of 1000 meter, but means millimeter means 1 meter. Okay. Now further I will for the drawing of columns I will select quick draw columns. Here I will select stiff column and dimension of column will be 450 millimeter by 450 millimeter. Okay. Now I will draw each column. Okay. Please make sure when the joint appears then click press. Here when the joint appears I will press the left mouse button. Okay, I have drawn all the columns. Now I will make the center points. Here when I click, basically the four edges are selected. I was unable to select the center point. For that purpose I will draw points with zero offset at the center. Okay, so that's how I will draw for whole slab. I have selected all the points. Now I will go assign load data, point loads, and I will select live load, and in the points loads I will put the column dimension 450 millimeter by 450 millimeter for the calculation of pump punching shear. And in the gravity load I will apply, for example, 1000 kilonewton downward load, and the moment is, for example, 230 kilonewton in the x direction, and the y direction maybe you can take it as 300 kilonewton. Okay, so these are the loads will be applied on each column. Okay, you can see the values in 3D here. In each column load has been applied. Okay, now I will define the soil subgrade properties, which is soil subgrade modulus. Modify. Here I will put the soil subgrade modulus. Here is for soil subgrade modulus. That is a pressure over deformation, means allowable bedding pressure over allowable settlement in the foundation. That values will come from geotechnical report. For example, if we have allowable bedding pressure that's a 200 kPa and the allowable settlement is 25 millimeter, then the soil subgrade modulus will be 200 divided by 25. That is the settlement. For example, in this case that the allowable settlement is 50 millimeter. Here allowable settlement for isolated footing that will be 25 millimeter, and for the raft/mat foundation that will be 50 millimeter. So here now I will put 50 millimeter and 1000 for the conversion. 200 divided by 50, answer will be 4000 kilonewton per meter square per meter. So that's the value I will put in the soil subgrade modulus. That will be 4000 kilonewton per meter cube. For the designing of foundation, please select the compression only. Okay. 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 Now I will make in the plan and select the slab. Okay, you can see I have selected the whole mat foundation slab. Assign spore data, soil properties. I am assigning the soil one, which is I have defined 4000 kilonewton per meter cube. Okay, okay, now you can see soil have been assigned in the yellow 3D. Okay, here you can see soil applied to the whole foundation. XY in the plan. Now I will apply design strips. Edit, add design strips for the design by strip based method. Okay, in the extraction you have seen grids have been drawn. Edit, add design strips and draw in the y direction, and the value will and the label is strip layer label is B. Okay, you can see, but here is some issue that software is not making the strips to the end. Please make it by clicking reshape command. Click here and make it at the end. Similarly this one. Please make all these so that you can see the detailed design by. Now I have extended all the strip layers to the end points so that we can get better results. Okay, XY. I have assigned the loads, boundary condition, strips, load combination. So now the step is run analysis and design. Okay, mat foundation. Okay, now I will check the deformation, display, show deform shape, load combination for service normal, apply. So the maximum deformation is 27 millimeter. Allowable in the mat foundation is that is 50 millimeter. So here the maximum deformation. Okay, now I will check the soil pressure against normal load combination, apply. Okay, so the maximum pressure is 108 kPa, so that is also less than 200 kPa, so it means our beading check is also okay. Now I will check the punching shear. For punching, all the checks are also okay, which is less than 1. So for checking of any check, right click, so all the information will appear. Unbalanced movements, maximum design shear stress, which is coming from the applied loads, concrete shear capacity. So punching shear is that is 0.88. Okay, now I will go in the display, show strip forces. I want to see, for example, movements, apply. Now I am seeing in the layer A. So here is the movement values. You can see these are for middle strip, these are for column strip. Similarly for Y layer, apply. So here you can see, so that's why we extended at the end so that we can get the results. Okay, similarly for shear, you can see the results. Okay, now for reinforcement design, I will go in the show slab design. For example, either by final determinant by strip based method. Here I have selected this layer A and B, apply. So okay, for example, let's see for layer A in the X direction. So here is a top and bottom reinforcement requirement. Okay, let's see for layer B. Similarly, you can see if I impose the minimum, apply, so you can see almost minimum is governing the criteria. So here some is the more enforcement. So what bars are required, how much reinforcement spacing should be. So here is the options. Here for example I will select 16 millimeter bar, apply. So let's reduce the spacing 200, 16, 200, apply. No more. For example I am reducing 120. I am just making more or less just for the uh, studying. You can optimize much better. Okay, so here is a additional reinforcement is required. You can provide extra bars in these portions. Okay, so now I will show how to detail this lab. I will run the detailing. There are multiple preferences, what bar you want to show in this lab. So all these things I will click run detailing. Okay, here is a drawing, slab views, framing plan, rebar table, rebar schedule, bill of quantities. So 27 metric ton reinforcement will be required. Individual mat view, rebar plan, top rebar plan, bottom rebar plan. So here is the strips, and the strips in the X and Y direction. Spacing are provided here. Top rebar plans. This is the mesh. How the bars will be look like here for the bottom. Here is the section of the mat foundation, and that's the profile, reinforcement profile. Reinforcement profiles are, for example, here. For example, in this portion, the required is, for example, that's the this green section is basically the our enforcement. The blue is the required enforcement. So that's the provided enforcement. The software is saying here the provided enforcement is 16.6% more. Here is 9.5% more. Here is 202% more. So that's the profiles for both, for layer A, for layer B. Okay, so that's all for the designing of mat foundation. Hope you got all the ideas about the mat foundation designing. So that's all. Thank you. Have a nice day.